So today is Unit 5, Day 2. We are in the triangle unit, or one of our triangle units. There's actually a couple of units that talk about triangles. But we are learning properties of triangles. And yesterday we talked about the 7 different classifications of triangles, right? There are 3 ways we can classify triangles by sides, and those were scalene, isosceles, and what was the third one? Equilateral. So by sides, we have scalene if they're all different side lengths, isosceles if 2 sides are the same, equilateral if all 3 sides are the same. And then we also talked about classifying triangles by their angle measures. Y'all remember what those 4 were? Acute means all the angles are acute. What else? Obtuse has one obtuse angle. Right has one right angle. What was the third one? Equiangular. All the angle measures were the same, and what would they have to be? Exactly all 60 degrees, right? So those are the 7 ways we can classify an angle. So today we're going to focus on, for a little bit, isosceles triangles. And we said that isosceles triangles have 2 sides congruent. So if you look at this picture right here, those red tick marks are showing those 2 sides have equal measures, correct? Okay, so those are called the legs of an isosceles triangle. The 2 sides that are congruent on an isosceles triangle are called legs. Okay, the angle where they meet is called the vertex angle. Okay, so where the 2 legs meet each other, that's called the vertex. And the 2 angles that come off of the legs are called the base angles. Okay, so the vertex angle is between the 2 congruent legs. The base angles are the other 2 angles. All right, do we have our theorem sheets out? Yes. All right. Find the base angles theorem. It might be on the back. Yes, at the bottom. It's on the very bottom on the back side of your paper. And I need to unzoom it so I can see everything. The base angles theorem is about 2/3. It says theorem 4.7. It's about a little bit more than a halfway down. Do y'all see it? All right, highlight that, please. The base angles theorem says if 2 sides of a triangle are congruent, which makes it isosceles, right? Then the angles opposite them are congruent. So segment AB and AC are congruent. So this is one side, the angle across from that is angle B. This is one side that's congruent, the angle across from that is angle C. So that means angle B and angle C are congruent to each other. So if 2 sides are congruent, then 2 angles are congruent. Okay, so basically in an isosceles triangle, you have 2 sides congruent and 2 angles congruent. Okay? All right. The converse of the base angles theorem. Now, what does a converse theorem do? Yeah, it does it in the different order, right? The conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. So y'all can go ahead and highlight this on your sheet. The converse of the base angles theorem says if 2 angles in a triangle are congruent, then the sides opposite them are congruent. So basically, if it says if base angles are congruent, if 2 angles are congruent, then the 2 sides are congruent. So it goes both ways. Okay? If 2 sides are congruent, then 2 angles are congruent. And if 2 angles are congruent, then 2 sides are congruent. Right? And that is for isosceles triangles. All right, good job. Did y'all highlight those too? Okay, so here's just an example. It'll probably take y'all longer to draw it than it is for you to answer it. So y'all just look up here. I figured y'all can do this. In triangle DEF, well, here's the picture. Segment DE is congruent to segment DF, and they're marked on the picture, right? Name 2 congruent angles. Yeah, so it's not the vertex angle. Angle D is the vertex angle, right? Right, not the vertex angle. It's angle E is congruent to angle F, right? Y'all agree? And that would be the base angle theorem. Everybody okay with that? If two sides are congruent, the two angles are congruent, but not the vertex angle. Okay, fill in the blank. Y'all draw this picture. It don't have to be perfect. Mine's not. I think I used a tool to draw it anyway.
We have 9 equals 12x minus 4x squared. So if we keep it 9 and we multiply.
How many different triangles are in this picture?
We need to move 2 terms of this problem, so we're going to add 4x squared.
3, right? 2 little ones put together make a big one.
And we get 4x squared minus 12x plus 9 equals 0. Yes, sir. Okay.
Okay, so they tell me on number 1, 2 segments are congruent. Are they marked in my picture? No, so mark them. It helps, trust me. So HG is congruent to HK. Whoops, trying to mark it. So that makes that triangle isosceles, that little one on the left. Y'all agree? Right? So I need to show what angle is congruent to each other. So ignore this other triangle. You don't need it. You just need this triangle to the left. What angles are now congruent to each other? Angle G and angle K. Y'all agree? Y'all agree? Are we okay with that? Okay. Now the next one tells you two angles are congruent. And using that information, we got to know what sides are congruent. Y'all see that? Okay, and just to keep out of confusion, they gave us the 3 letters for the angles because there's more than one angle H and more than one angle K, right? So angle KHJ, which would be this angle, is congruent to angle KJH, which is this angle. Okay? Therefore, what segments are congruent? Yep, so those would be the base angles of this triangle over here to the right side. Do y'all see that? So if these 2 angles are congruent, then these 2 sides are congruent. So segment HK is congruent to segment KJ or JK. Is that okay with everybody? So if you know 2 sides are congruent, then you know 2 angles are congruent. And if you know 2 angles are congruent, then you know 2 sides are congruent. Okay? Is that okay with everybody? We good? Okay. So find the corollary to the base angles theorem. Is that the next one down on the back? Next to the last one? The corollary, remember a corollary we learned yesterday is a statement based off of a theorem, right? We take a theorem and this is just a branch off of it, okay? So the corollary to the base angles theorem says if a triangle is equilateral, then it is what? Equiangular. So obviously if it's equilateral, then there's 2 sides congruent because there's 3 sides congruent, right? Right? Well, that would also mean, like, okay, ignore BC being congruent. If AB and BC are congruent, that means these 2 angles are congruent, right? Right? And subtracting their measure from 180 would get you this angle, so they would all 3 be congruent. Okay? Y'all see that? So all sides being congruent means all angles are congruent. So if it is equilateral, then it's equiangular. And then the corollary to the converse of the base angle theorem says it the other way. If it's equiangular, then it's equilateral. So that goes both ways too. It's an if and only if statement. The hypothesis and conclusion theorem and the converse are both reversed. So if a triangle is equilateral, it's equiangular, and if it's equiangular, then it's equilateral. If all the angles are the same, then all the sides are the same. And if all the sides are the same, then all the angles are the same. Make sense? Okay. Find the third angle theorem on your handout. It's on the front page, isn't it? It's about a third of the way down. Theorem 4.3. Okay. The third angles theorem says if two angles in one triangle congruent to two angles in another triangle, then the third angles are also congruent. Okay, so if we have two triangles and two sets of angles are congruent, then we know the third ones are congruent. So do you see that picture beside that on your handout? You see how A and D have two tick marks inside the angle? Okay, that means those are congruent with each other. B and E have just one little arc mark, so those are congruent to each other. So they're saying if two angles are congruent to two angles in another triangle, then the third angles are congruent. So then we would say that angle C is congruent to angle F also.
All right, now let me just go ahead and say this.
All right, this is simple. Find the measures of angle P, Q, and R. All right, because what kind of triangle is it showing? Equilateral, and we know if it's equilateral, it's also equal angular, and we already talked about the measures of the interior angles of an equal angular triangle are what? All 60 degrees. And 60 plus 60 plus 60 equals 180. Okay? Write this one down. Draw. The vertex angle is 50 degrees.
Especially on this one, if you write so large that you're not gonna be able to clearly show all of your work and you read it, then where do you think it needs to be done? On notebook paper and then put your answers on this sheet. Like your factored answers and numbers and so on. That makes sense. Okay? Now, I can write small enough to fit it on, because I've done it with the students that aren't here.
All right, so I have this triangle XYZ. Angle Y is 50 degrees. And what is it telling me about the segments X, Y, and YZ? They're congruent. This makes that triangle what kind of triangle? It's isosceles, right? And we just learned about isosceles triangles. If two sides are congruent, then what? Two angles are congruent, and it's the base angles, right? So 50 is the vertex angle. So that means angle X and angle Z are congruent to each other. Okay? So how can we find the measures of angle X and angle Z?
Alright,
And then what? Divide by 2. Very good. So you're going to say 108. I don't know what that crap was. 180 minus 50 equals what? 130 degrees. And then since these two are going to be the same, we're just going to divide this by 2. Take half of it, right? Split it up. And what is 130 divided by 2? So the measure of angle X is 65 degrees. And the measure of angle Z is 65 degrees. How could I check it? Add 65 plus 65 plus 50, and they all should equal what? 180. Do they? Yes, they do. Any questions about that? Okay. That's a funny looking picture. Apparently I copied and pasted something and tried to do something. I don't know. But it's got a triangle, then it's got like a triangle kind of sticking out to the side. Y'all see that? Draw that if you can. I'm just looking at y'all's practice to see if there's anything crazy on it.
So I've already told you, when we leave over this one, you go straight to the line on the factor, so X minus 6 and X minus 8.
I'm not seeing that. Nothing crazy.
So now, how to figure
Okay, so this is Y, and it's an angle measure, and that's X, and it's an angle measure. I don't like where that X is.
Okay, you're looking for
Let me see if I can fix it.
X minus 6 or X minus 8. So I don't see that in 1, 4, 7, or 10. I don't see that in 2, 5, 8, 11. But I see X minus 6 on number 6.
That's a little better looking at it. You can't really see it though. I want a fat X. Oh, sugar.
So now if you look at the color, you should find extra space
So
for
touchy. I'll leave the degree sign in.
dark blue.
Sorry, y'all.
So if you turn your picture over, wherever you see a number
That's
6,
better.
what
Good
color
job.
is it? Dark blue.
All right. X or Y. Do y'all see all those tick marks? Those are kind of important, right? Okay, I'm gonna do the big triangle first. What kind of triangle is this triangle? Equilateral, because it said they both have 2 tick marks, right? If they all have the same amount of tick marks, that means they're all congruent sides, right? So if it's equilateral, it's also equiangular. All right, so it's equiangular. So what is the measure of angle X up there? 60 degrees. Very good. X equals 60 degrees. Are we okay with that one? Now we got to find Y. Do we have enough information to help us find Y? How can we find Y? I'm trying to make my pen a little skinnier. Okay, why would I do that? Okay, yeah, it has that right angle symbol right here, right? And we know that's the equilateral triangle, so this is a 60-degree angle. Y'all see that? Okay. So that means this little part of this angle right here has to be how much? 30 degrees. Y'all see that? Now, what kind of triangle is the triangle with the Y? You can't assume obtuse. It's isosceles, right? Because it has 2 sides that are congruent. Y'all see that? Okay. So if it's isosceles, is this Y that we're trying to find a base angle or the vertex angle? Vertex angle. And I already know one base angle, correct? So what's the other base angle? It's also 30 degrees, right? Y'all see that? Because base angles are congruent. So how would I find Y? So it's going to be 180 minus 60 equals how much? 120 degrees. Ooh, that looks like 1200. 120 degrees. Cute. So we okay with how we got 60 and 120? Okay with that? Okay. So use your little tick marks that tells you if things are isosceles or equilateral or whatever. Okay? All right. This is our little intro to congruence of triangles. Okay, so this is kind of switching gears. Okay. You kind of need to write all this down. I apologize. I'm going to hush for a little bit and let y'all write this down.
The quiz tomorrow
You can read it.
does not cover this section.
So we're going to start talking about congruence because we're going to start proving triangles congruent tomorrow. So this is our kind of little introduction to that.
What we did yesterday
Okay.
and what we did the day before. Solving quadratic.
So we need to know what congruent means and what corresponding means.
Multiple choice, multiple response. Now, the biggest thing we get, no, I don't like multiple choice, I'd rather have a short answer. Right? I understand that. But your EOC is multiple choice, multiple response, and that's get correct for your EOC. And that's what we need. Okay? So, does that mean that you can't show work on this? No, you can show all the work you want to. I just don't grade your work. I grade your time land. Now, again, I said it multiple times, I'll say it again, some of us need to get out of our minds that have them, I can show any work and I can just give an answer right. And I'll tell you that some of you must be lucky guessers, because these problems, I can't even do it without showing work. There's some secret magic trick, it's mathematically correct. You're not letting me in. Yes? All right, so it is multiple choice, multiple response, and it will be 20 questions. So that's what we're looking at as a quiz. Good deal? All right, so let's look at today's notes. All right, simplifying radical expressions is what we're doing today. So like I said, this is a prereq to the lessons that we're going to be doing next week and the week after. Very important lessons. This necessarily is not a state standard. but it just leaves us up to our state standards. So what we can do by the end of the day is simplify radicals and radical expressions. A radical expression is in simplest form, when no perfect square factors other than one are in the radicand. We'll talk about what that means. And before we move on, when I say a radical, that means the square root symbol. Yes? So that's what a radical is, square root symbol. So what's underneath a radical is called the radicand. No fractions are in the radicand, and no radicals appear in the denominator. Where's the denominator? The bottom of the fraction. All right, so let's look at this property. The product property of radical says that the square root of a product equals the product of the square root of the factors. Now, with that being said, all it means is if we have a product underneath the radical, underneath one, we can rewrite that as a radical times a radical. If we don't start paying attention, I'm going to hand you your assignment and you can do it without my notes. How do you feel when you worked hard for a presentation in a class and you get up in front of the class and you see kids not paying attention to your presentation? How's that make you feel? Not good. You put all the effort in and all the work in. It's the same thing with me every day. At least be respectful enough to look at the screen and look at your paper. Is that understood? So if we have a product underneath one radical, we can split that up as a product of two radicals. That's all that means. Okay? And actually what we're going to do later, we're going to have multiple radicals. And y'all, when you multiply radicals, you just multiply what's on the outside.
About done? All right. So, congruence. Two geometric figures. It don't matter if they're circles or triangles or squares, rectangles, any kind of other shape, pentagons, are congruent if they have the same size and the same shape. Okay? Two figures are congruent if they have the exact same size and the exact same shape. Okay? So, think back to transformations. Y'all remember those? Lots of graphs. We have rotations, translations, reflections, and dilations, correct? All right. Which one of those kept everything the same size and same shape?
Are we okay with that?
Reflections, rotations, and translations. So which one is the only one of those transformations that did not keep the same size and shape? Dilations. They kept the same shape, but they got different sizes, right? Sometimes they shrunk and sometimes they enlarged. All right? So any of those transformations will make a congruent figure. Correct? So we're going to start, like after the end of all this stuff, is we're going to go back and relate this to transformations. Right? So one thing we'll do before we take our benchmark is go and really review and look at transformations in terms of congruence and how they relate to each other. All right? So if two figures are congruent, then all the parts are congruent to the corresponding parts of another figure. So if I have a triangle, then there's an angle that matches up with every angle, and there's a side lane that matches up with every side. Okay? So corresponding parts means the parts that go with it. All right, just write down this right here. Triangle JKL is congruent to triangle TSR. Just write that down. Triangle JKL is congruent to triangle TSR. When we name triangles and put them in a congruency statement. Now, a congruency statement is saying that one is congruent to the other. Okay? When we name triangles and put them in a congruency statement, the placement of the letters is very important. It matters the order. When you're saying one triangle is congruent to another triangle, it is very important where you put each letter. And here's why. When you have a statement of congruency and it says angle J is mentioned first, well, the first letter in the second triangle better be congruent to it. And so angle K is congruent to angle S. And angle L is congruent to angle R. So I'm going to write those down first. Angle J. So I'm listing all my congruent parts. Angle J is congruent to angle T. The first is congruent to the first. The middle one is congruent to the middle one. Angle K is congruent to angle what? S. And angle L is congruent to angle what? R. So when we're writing a congruency statement, it's very important how you match up the letters. All right? So in congruent triangles, the angles are congruent, and also what else is congruent? We got sides, right? Sides are line segments, aren't they? Right? Okay, same thing with segments. Let me show you with my fingers before I write them down. Segment JK is congruent to segment TS. Segment KL is congruent to, what do you think? SR, and then you split them. JL is congruent to TR. Okay? So now I'm going to write those. JK, segments need bars over them. Remember that. Segment JK is congruent to segment TS. Segment KL is congruent to segment SR, right? And segment JL is congruent to what segment? TR. So the placement works for both angles and segments in a congruency statement. Okay, so these are the angles that correspond with or the angles that correspond with each other, and these are the sides or the segments that correspond with each other. Okay, go with me? You got it? So the name tells you all of these 6 things. Okay? It matches up what angle goes with what angle and what sides go with what sides. That's pretty cool that I can get all of this from just this statement, right? Pretty cool. All right. So these are what kind of figure? Quadrilateral. All right. So quadrilaterals, they don't have like a little shape in front of them. They're just 4 letters beside each other. Okay? 4 letters squished together is a quadrilateral. All right. Now, same thing. This is a congruency statement. So that means the placement of the letters matter. Okay? So I don't even need the pictures. Okay, yes, I can say angle B and A are right angles and C and D are right angles. And that's just something I can use to check myself. All right? Because we know right angles are going to be congruent to other right angles. Right? Okay. So we can use that to check ourselves, but I don't even need the pictures to list the corresponding parts. All I need is that statement of congruency there. All right? So y'all help me do this. Angle A is congruent to what? Angle C. Angle B is congruent to angle D. Angle G is congruent to angle E. And angle H is congruent to angle F. Any questions about the angles? Those are easy. Sides could be slightly more complicated. All right, so then we go to our segments. Segment AB is congruent to what segment? CD. I'm just going to go down. BG is congruent to DE. GH is congruent to EF. And what am I missing? AH. What did that line come from? Did y'all see that? AH is congruent to which one? CF. There we go. We identified all the corresponding congruent parts. Okay with that? Yes. CD, probably erased it. I think what happens is it scooted that line down there. I don't know what happened. I'll have to go back and watch the video and see. All right. At least I can do that, right? In case I just want to solve the mystery. All right. Number 2. So we got these 2 quadrilaterals. And look, I'm going to check my angles. A is a right angle. Is C a right angle? Yeah. B is a right angle. Is D a right angle? Yeah. And I don't know much else. Angle F is 105 degrees. So what other angle is 105 degrees? H, right? Well, that's going to help me find the next thing. Number 2 says find X and the measure of angle X, angle H. So what can I do there?
4x plus 5 equals 105.
Right, H and F correspond with each other, right? So those angles are congruent. So I can set 4x plus 5 equal to what? 105. So how do we solve this for X? Subtract 5 everywhere. So 4x equals 100 divided by 4 and x equals 25. And then it says to find the measure of angle H. Well, I already know that it's got to equal 105, right? Right. And I can check that by plugging in. 4 times 25 plus 5 is 105. Right? So any questions about corresponding parts? We'll talk more about that tomorrow. We're going to start proving triangles congruent tomorrow. And that's the end of notes for today.